Have you ever had one of those light bulb moments for a gadget, but then, you hit a wall feeling like the world of electronics is just way too complicated to even get started? Well, we're going to change that today. We're breaking down the essentials, giving you a crystal clear roadmap to go from a simple idea to a real deal invention. So let's pull back the curtain and take a look at the inventor's blueprint.
Okay, I know what you're thinking. This looks intense, right? But I want you to think of this as our map for this whole journey. We're going to follow this path together, step by step. We'll start with the absolute basics, then see how they all fit together, and finally look at how you can bring your own ideas to life. It's the same logical journey every single inventor takes.
All right, so first things first. Before we can even think about building anything, we need to learn how to read the plans. And in electronics, that means learning the universal language of circuit symbols. Think of this sheet of symbols as the alphabet of electronics. Seriously. Just like letters form words, these symbols combine to create circuit diagrams, or what we call schematics. Each little drawing represents a unique part with a very specific job. So let's start by meeting two of the most important letters in this entire alphabet, the resistor and the capacitor. So, meet the resistor. Its job is super simple, but absolutely crucial. It controls the flow of electricity. It's kind of like a valve on a water pipe. Resistors are the traffic cops of the circuit world, making sure every single component gets exactly the right amount of power it needs. You know that tiny LED power light on your TV? The reason it's not blindingly bright is because a resistor's in there, taming that current.
So how do you know what a resistor's value is? Well, here's the cool part. You don't need a magnifying glass to read tiny print, you just have to crack its color code. These colored bands are a universal system that lets you instantly know a component's exact resistance. It's an incredibly smart design that lets you see everything you need with just a glance.
Next up, the capacitor. Now, if a resistor is a valve, a capacitor is like a tiny, super fast-charging battery. It stores up energy and then releases it in a burst when it's needed. Think about the flash on a camera. It charges up for a second, and then bam! It releases all that energy at once. That's a capacitor at work. And that ability is vital for everything from creating timers to smoothing out the power supply so sensitive parts don't get fried.
And yep, you guessed it, just like resistors, capacitors have their own markings. Learning to read these little numbers and letters is another key step. They'll tell you everything you need to know, its capacitance, its voltage rating, and more. It's all part of becoming fluent in the language of electronics.
All right, so we've met the key players, but let's be real. A pile of parts doesn't make a gadget, right? Now we're going to see how combining these components is what creates circuits that actually do stuff. This right here gets to the heart of it. Individual components, they're just parts. They don't do much on their own. The real magic, the intelligence of a device, that happens when you start arranging them in clever ways to perform tasks and even make simple decisions.
Okay, and this is where it gets really, really cool. Using just a couple of simple parts, we can build what are called logic gates. The AND gate over on the left will only turn on if all of its inputs are active. But the OR gate on the right, it's more chill. It only needs one of its inputs to be on. This right here, this simple idea, this is the absolute foundation of all digital computing. It's how we make choices with electricity.
Building everything from individual parts is awesome, but it's slow and, well, it's bulky. That brings us to what is probably the single biggest leap in modern electronics, the integrated circuit, which basically shrinks entire massive circuits onto one tiny little chip. An integrated circuit, or an IC, is pretty much a modern miracle. We're talking about a complete circuit with resistors, capacitors, and sometimes millions or even billions of transistors, all baked onto a piece of silicon smaller than your fingernail. This is what makes our modern world possible. It's how we pack immense power into such tiny spaces.
Just to give you an idea of the difference, take a look at this schematic for a motor controller. To build this thing the old-fashioned way, you'd need all of these individual, what we call discrete, components. It's complex, it takes up a ton of physical space, and every single one of those connections has to be perfect. Or you can take all of that complexity, all those functions, and embed them onto a single silicon chip. That's the power of integration. And it doesn't just make circuits smaller, it makes them way faster, far more reliable, and unlocks a level of complexity that would be basically impossible otherwise. So we've covered the language, the components, and the brains. Now for my favorite part, the most exciting part, taking your idea from a blueprint and turning it into something you can actually hold in your hand and test out. Let's talk about building a prototype.
And you know what? This whole process really just boils down to two fundamental steps. First, you draw the schematic. That's the plan. Second, you build the prototype. That's the test. I'm not kidding. Every single electronic device in the world, from a simple kid's toy to a massive supercomputer, starts in this exact same way.
This brings us back to the golden rule of inventing. You have to start with the schematic. It is your non-negotiable blueprint. A clear schematic shows every single component and every single connection. Getting this right on paper first will save you from countless hours of frustration when you actually start building.
And then comes step 2, the prototype. For this, let me introduce you to every inventor's best friend, the solderless breadboard. This thing lets you just plug in your components and wires to bring your schematic to life. And the best part? If it doesn't work, you just unplug a wire and try again. No mess, no permanent mistakes. It's the perfect canvas for experimentation.
And that's really the whole journey, from a theory on paper to a tangible prototype you can test. You now understand the language, you've met the key components, and you know the process. The inventor's blueprint is officially in your hands. So the only question left is, what are you going to build first?